So in this example, we're gonna go we're looking at a digital voltmeter, and the digital voltmeter uses a 10-bit single ramp analog to digital converter. Okay, um, so the range of the analog to digital converter is 0 to 10 volts, and we're given that that ramp analog to digital converter has a sample rate of 100 kilohertz. Okay, so for an applied voltage of 6.372 millivolts, 6.372 volts, what is the digital voltmeter output value? All right, and we want to also know how long will the conversion process take. Okay, so in order to do this, the first step we're going to do is we're going to determine what is our quantization level for this converter. So the quantization level is defined by the range of the converter. So the range of the converter is between 0 and 10 volts. So we have a 10 volt range, and that would be divided by the number of bits. Right? So in this case, we have a 10-bit converter. So 2 to the 10. All right, 2 to the 10 is the same thing as 1024. So 1024 bits. All right, and then we get that, we end up getting 9.77 millivolts per bit. All right. So what we want to kind of look at is how the successive the single ramp analog to digital converter basically does is it keeps increasing the value of Q of the comparing the signal that it's comparing to the input signal, and it ranges by so it slowly determines that, and each time it basically increases a step. It basically increases the value slightly by one. So basically, the first time it goes through, the value will be 0. The second time it'll be 9.77, and then it'll be 2 times 9.77 millivolts, then 3, etc., until it reaches the value that we're interested in. So this slow increase is we're going to call this our slope. And so we're going to say that 9.77 millivolts per bit, and we're going to say that the ramp analog converter basically goes 1 bit every time it runs a step. All right, so we're basically going to say that we basically have 9.77 millivolts per step. All right. So now we're going to use the clock. We're going to we're going to use this value to determine the number of steps that the ramp converter needs to make until we get to the measured value. So we're going to divide. So we're going to calculate the number of steps by basically taking the input voltage, which was 6.372 volts, and we're going to divide that by our 9.77 times 10 to the minus third volts per step. Right, this will give us our number of steps. So the number of steps required is going to be 653 steps. Okay, so the device can only measure either at or below at a given quantization level. So to determine the actual reading of the device, we're going to multiply our number of steps by our number of volts to get our reading. So our voltage reading is going to be equal to 653 steps times our number of bits, our bits per step, so 9.77 millivolts per step, and what we end up getting here is we get a value of 6.3769. Okay, all right. Now the voltmeter that we were using was a 3-digit voltmeter, so it can only display 3 digits. So we're going to round this up to 6.38 volts. That is our voltage reading on the screen. Right, and then the second part is how long will the conversion process take. So for the conversion process, what we have to do is we have to take the number of steps, and we have to multiply that number of steps by the by the clock rate. So we basically have 100. So one basically we I guess divide by the clock rate. So the clock rate is basically 100,000 samples per second. So we basically say steps per second. All right. So we're basically dividing by 100,000. So we end up getting 6.53 milliseconds for the time. Okay, so 6.53 milliseconds doesn't sound like a crazy amount of time. It gives you a good accurate reading. So for a digital multimeter, this is probably a good suitable system. But if you were trying to acquire a dynamic signal that had values in like the thousands of hertz, this ramp type analog to digital converter would not be a great option for you. Um, so, um, so it, so that's just some things to keep in mind when you're looking at your the the data acquisition voltmeter or a data acquisition device is just what type of converter it uses. You can kind of estimate how fast it can do its calculation and determine the certain value that you're interested the voltage value that you're interested in.